and turn on the captions. And I'm just going to kind of go with it and go with the question. And if you have questions, just throw up your virtual hand so I'll see it. I appreciate it. Y'all see the problem I got on the board? Well, 4.211. Give me a thumbs up. Go ahead and write that down. Put it in your, I want to get to the second part right here, that part right there. Because this is the part that's throwing everybody off. B is in the other classes. So I'm going to write it down so I won't have to refer back to the question when I put it in Excel. So we've got 30, 40, 50, 60, and 70. These are our observed X's. Observed X and observed Y. These are actual points. 91, 87, 83, 74, and 62. And they want us to pick out 2 points, and they're picking out 40 and 87, and 70 and 62. Now, we're going to get a line of regression using those 2 points. So before I even start on the Excel spreadsheet, we're going to do this by hand. So there's our observed X, observed Y, and they want us to form a line of regression using 40, 87, and 70, 62. Now this part is not confusing to students. It's the next part that's confusing because they want to do a residual against the equation we're about to get, and that's what's confusing students. So go ahead and get our slope. 62 minus 87 over 70 minus 40. Negative 25 over 30, which is negative 5 over 6. And I have no idea, is that 0.83? Negative 0.83 repeating, I think. Let me check right quick. 6 divided by 7. Oh, I'm sorry. I don't know where 6 divided by 7 came from. I guess that's just 5 divided by 6. Yeah. Okay, now I'm showing you this problem because it's in your homework. So please pay attention. Okay, even though the sound is not off, I appreciate if y'all pay attention. All right, y minus 62 or y minus 87, you can pick either one. Y minus 87 is equal to negative 0.83 times x minus 40. Sorry. And I use this point, 40 and 87. And now that's going to be y minus 87 is equal to negative 0.83x plus, I have no idea what 0.83 times 40 is. So times 40, 33. So y minus, well, plus 33.3 repeating. And y is equal to negative 0.83x plus 87. Y'all check my math, please. I got 120.33. Somebody check that for me. So that is our line of regression using 2 points. Did everybody get those same numbers? Give me a thumbs up or down. All right. Now, the next part is where students kind of get flaky on me. So I'm going to go to the Excel spreadsheet, and we're going to do the next part. And I'm punch this in. It's negative 56x plus 120.3, and it may not like it because it's a decimal. So I don't know. I'm not going to worry about it. That's the answer. So 361 over 3, that's 120. Yeah. Okay. Now, this is the part, not this part, but the next part. Let's see, it's a negative slope, so it's either B, C, or D. I'm just going to pick one. I haven't graphed it, so I have no idea. It's either C or, I don't know, C or D. Let's see if D fits it. Okay, and this part right here, well, okay, it must be E or F. I can't remember, but they want you to run a regression of that point, of that equation. So I'm going to go to the Excel spreadsheet. And you can follow along. And I'm going to blow it up a little bit. And I guess that looks about right. And I'll color the back a little bit. There you go. Now, I'm going to go ahead and make this bold, underline, and I'm going to spread this out a little bit. Now, we got to have, here is the observed values. There's our observed Y. We've got to have a predicted Y in order to get the residuals. So here is our, and what I'm fixing to do is, let's highlight this. Well, I can't. This is predicted Y with our 2 points using this formula right here. Okay, so that's going to be equals parentheses negative 0.83 x, which is 30. You got to do times x plus 120.333. And there is your predicted Y. Now, somebody tell me what the residual is. What is the residual? That means I want somebody to unmute their mic and tell me what the residual is.
Y minus Y hat.
Yes. Y minus Y hat, meaning, and this right here is Y hat. Y minus Y hat, the predicted Y is the Y hat. So Y minus Y hat is going to equal Y minus y hat. Oh, me. And copy that down. And the next column is going to be, you're going to square that. Y hat. I'm sorry, residual raised to the second power. And copy that down. And can somebody tell me what we're supposed to do with the residual squared? What are we supposed to do with the residual squared? That's a cue. That means I want somebody to answer it because somebody knows it. They're just not wanting to communicate. So I'm just going to wait until somebody says something.
Add them together.
You add them together. Good. I know you're not supposed to communicate, but I appreciate it. There you go. And that right there is the number they want somewhere in the homework problem. But remember, that number right there, 50.98, is based on how many points? Two points. That number right there is based on 2 points, which is based on that equation. Everybody with me? So this means, since it's a large number, it's pretty large compared to these numbers right here. It's about the same as these numbers right here. It's pretty large, relatively large. And what they're trying to get you to see in the homework is if this number is relatively large, then these 2 points are not very accurate in predicting the line of regression. That's what they're trying to show you. So now we're going to do all 5 points. So now we're going to do all 5 points. So I'm going to take this and I'm just going to copy this down. And put it right here. And I'm going to erase this. And erase that. And now we're going to do the line of regression using not 2 points, but all 5 points. And we're going to go to Insert, Chart Plot. And we can do this with technology because the original we had to do by hand with 2 points. Add trend line, display, and display. And here is your new, this is your new equation for your predicted values. Right there. So I'm just going to move this over here a little bit. Get that out of the way. And now my predicted Y is going to be equal to, parentheses, negative 0.71 times X plus, hold on, plus 114.9. And you're going to copy that down. And here you're going to subtract, just like you did before. Copy it down. That doesn't look good. I don't know what I just did. I think I'm losing my mind. 91 minus and now I square it. And add all those numbers up. And I can pretty much guarantee you that this number is going to be smaller than 50. Now, am I just a telepath? Can I tell the future? Or is the law of large numbers tell us that the more you put into it, the more you're going to get out of it? The law of large numbers tells us that the more you put into it, the better your outcome. If you just pick 2 points, your prediction is going to be crappy. If you pick 5 points, your prediction is going to be a whole lot better than crappy. And that's what they're trying to get you to see. 5 points is better than 2 points. Does everybody understand that? Law of large numbers? If you're working for Michelin, you don't want to pick 5 tires, you want to pick 500 tires. You know, if you're predicting for next year's defective tire budget. You don't want to be lazy. Lazy gets you fired. Okay? And I don't care if you're a quality assurance manager or a mechanical engineer for one of those companies. If you're lazy, it's going to show up somewhere, whether it's in mathematics or whether it's in designing, you know, whatever. So it can be in research or it can be in building the next greatest thing. So that's what they're trying to get you to see. This number is naturally going to be lower than this number because you're using more points for the line of regression. Okay, and I'm done with residuals. That's it. I'm done. So you should be able to do those. And I'll extend the homework a little bit just to let you finish up those residuals if I haven't already extended it. I know I extended it for the other ones. I just don't know if I extended it for this class. Now, how far did we get in 5.1? Did we get to the sample set spaces like 3 children, 4 children, and the 2 die? We did? Okay, let's go over that right quick because I want to make sure everybody's up to snuff before we go into 5.2 and 5.3. So let's do, what is the probability? These are more like single probabilities. What is the probability of picking a face card out of a deck of cards? Anybody want to take a stab at it? Means unmute your mic and say something if you know it. Anybody? Nobody in the classroom knows how many face cards are in a deck of cards.
It's like 16 out of 52.
That is close, yes, but it's not 16.
12 out of 52.
Say again?
12 out of 52.
12 out of 52. So there's 2 correct answers. I think you were thinking 4 times 4 instead of 4 times 3. There's 3 face cards in a deck of cards. The queen, the jack, and the king. So 4 out of 52, and you can reduce that down. I'm not going to worry about reducing it down. Either reduce as a fraction or change into a decimal, whichever the directions tell you. Make sure you can do that. All right, that's a single probability. How about the probability of an even number on a die? You roll a die. What is the probability of an even number?
3 out of 6.
3 out of 6, and you would reduce accordingly. And of course, y'all know that's 1/2 or 0.5. And what is the probability of rolling a 7 on a die?
Zero.
I think you said 0, right?
Yep.
That's a kind of a trick question, but people miss it on tests. And it's also on a standardized test. They like to put these on a, make sure if it says die and not dice, 0. So what is the opposite of single probabilities? That's your sample spaces. Did I send y'all a word processing sheet with the sample spaces on them? Yes or no? Okay, I'll just look. If I hadn't, I'm going to send it right now because I'm looking. I don't see it. There it is. Yep, I did send it, so I'm going to pull it up. Of course, I know only 2 of y'all probably printed it out. There is your sample spaces. So let's do a couple of these. What is the probability of at least one girl out of 3 children? Okay, somebody give me that number. What is at least one girl out of 3 children?
Three out of 8.
Well, you're partially correct. It's 7 out of 8. Now, let me ask you the same question, but differently. What is the probability of one girl with 3 children? Say that number again, whoever said that.
3 out of 8.
3 out of 8. Did I get you? What's the difference between the 2? That means I want somebody to say something. What's the difference between the 2? What's the difference between the 2 questions? I underlined it. Now I'm going to highlight it. Boy, y'all must have been eating a lot of them Tide Pods. What's the difference between the 2?
At least.
One says at least. That means you at least got one girl. Let's go back. Where is at least one girl? Well, 3 girls is at least one girl. 2 girls is at least one girl. There's 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 at least one girl. So your answer is 7/8. I guarantee you I got half the class on this one. A lot of you probably put 3/8. 3/8 is one girl out of 3 children. So be careful with the wording. I could put at most and get you again. How about the probability of rolling a 7 with a pair of dice? Rolling a 7 with a pair of dice. There's a 7. 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 So what's the probability of rolling a 7 with a pair of dice? 6 out of 36, Hubert. Yep. So these 3 questions are real simple if you what? If you have the sample space. But like I said, only 2 or 3 of y'all are going to actually print that out. So your decision. Question, gripe, complaint. All right. So out of 5.1, there's your 2 types of examples. A single, meaning theoretical or observed, meaning just one probability, or a sample space, which I've given you the 3 that I would. Now, I'll give you one more that you might see on a sample space. What is the probability of getting tails with 2 coins? Well, all you got to do is go to your boy, girl, or you can do tails, heads, 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 tails, tails, heads, tails, tails. So where do you see 2, or what is the probability of getting 2 tails with 2 coins? 1 out of 4. So you can do the sample spaces all day long. And that's 5.1 revisited. And what about 5.2? Well, 5.2 and 5.3. 5.2 is the additive law, and 5.3 is the multiplicative law. .2, you only have to worry about one thing. Always subtract the overlap. .3, you got 2 things to remember. With replacement, which is called independent, and without replacement, which is called dependent. Without replacement does not affect the math. Without replacement does affect the math. And those are the 2 things that you need to remember about the additive law and the multiplicative law. Now we're going to do 2 example of each before class is over, and then hopefully y'all will send questions, which I doubt, Wednesday or Thursday. All right, so let's do, and most of the time you want to try to do the multiplicative law with a table. In other words, create a table. Makes things a whole lot easier if you can. So with that being said, I like to do the blood types as an example for the additive law. Blood types, Rh positive, RH negative, A, O, B, AB. Two, 4, 6, 8, 1, 3, 5, 7. Oh, I forgot one more thing on the most important thing on the additive law. The key word, anybody know the key word for the additive law? Or. Anybody know the key word for the multiplicative law? And. So the probability of this or this, that would be the additive law. What is the probability of this and this? That would be the multiplicative law. So, I want to know the probability if I was to put all these, all these types in a hat, and 2A, 1A negative, O negative 4, and put all of them in a hat, what would be the probability of picking an A type or a B type? So the first thing you need is your denominator. And somebody tell me how you get the denominator here. What's the denominator? What are you going to do to get the denominator with a table? Just like a frequency distribution. How do you get the denominator with a frequency distribution or a table? Y'all know a relationship that one side doesn't communicate? You know what that usually ends up, don't you? A boring relationship. So I don't want any of you to say that this class is boring, because you know why this class is boring? Because y'all don't communicate. That's why it's boring. How many of you have ever been in a relationship with somebody? They don't talk. Anybody? Y'all haven't been in any relationships? None of y'all have had a girlfriend or a boyfriend that didn't talk? How was that relationship? Anybody? Y'all must really suck. Okay, well, that's why everything's so quiet in here, because y'all won't communicate. So I'm going to ask the question again. What do you need for the denominator? What do you do for the denominator when you have a frequency distribution or a table? What do you use? What do you do?
Count them all up.
Thank you. And what is the summation of all these? Well, there's a 10 right there. There's a 10. So 20, 28, 35, 36. Is that what y'all got? I got 36. That's what I got, Hubert. Good. All right, now I'm going to take my pink highlighter, and I'm going to highlight A. And I'm going to take my green highlighter, and I'm going to highlight B. And with my pink pen, I'm going to write 2 plus 1. And with my green pen, I'm going to write 6 plus 5, and we're adding there, and we're also adding here, because it's the additive law, and we always need to subtract the overlap. Do we have an overlap here? Yes or no? No. So we subtract 0. Now, I know, I've got several degrees, and I got running water in my house, and I do have several teeth in my head. I do know that there's no overlap here. But what I'm trying to show you is that always remember the overlap, because when you remember the overlap, you won't get this problem wrong. So, equals 3 plus 11 minus 0 over 36. And that comes out to be what? 14 over 36, and you reduce accordingly and decimalize if the directions ask for it. Okay? So that's one question I could give you on the additive law. Okay, next one we're going to do the same table. RH positive, RH negative. Same numbers. A, O, B, and AB. Two, 4, 6, 8, 1, 3, 5, 7. I want you to do this one. I want the probability of picking O, R, RH negative. So go ahead and put everything over 36. All right, I want y'all to do this one. Go ahead and start. And I would suggest using a highlighter or 2 highlighters, because it might give you an indication of the overlap using highlighters. Or crayons, whichever you have. So I'm going to highlight my O in pink and my RH negative in green, and 4 plus 3 and 1 plus 3 plus 5 plus 7. And somebody tell me what my overlap is. Thank you, Miss Jarrett. I appreciate the communication. You hold up a number 3. That's y'all's communication. Way to go. Minus 3. Good God, I've never seen people that can't communicate. Just blows my mind. Y'all are the people that when I walk into a classroom at the college, y'all are sitting in the dark. Y'all won't get up to or tell somebody to get up to turn on the light. Y'all just all sitting in there in the dark. Blows my mind. That's all right. You'll start communicating, or you'll get fired, one of the two. All right, so that's 7. But the sad thing is, some of y'all it's going to take to your second, third job till you start to understand it. 1 plus 3 is 4, plus 5 is 9, plus that's 16. Y'all please check my math. Minus 3. And that's going to be plus and over 36. 7 plus 16 is what? 23. Minus 3 is 20. I got 20 over 36 and reduce and decimalize as needed per directions. Is that what everybody got? And that's how you do the 2 types of problems: overlap, no overlap, and overlap. That's why it's always important to try to put it. Now, you're not going to be given a table all the time. Sometimes you're going to be given a paragraph, and you need to decide if you can put it in a table or not. And it kind of helps to do that. Okay, that's the additive law. The multiplicative law. I like to show students the multiplicative law by using a bag of marbles. And I didn't say Marlboros like Marlboro Reds. I said marbles. You know, the little round glass things. Okay. Now, this is also a question on your test, and it's used golf bag. So you can use marbles or golf balls. This is the same type problem. I know the test questions, there's 2. There's a marble and there's a golf ball. But I don't know if there's others. But so in this marble bag, we have four blue marbles. This is supposed to be blue, but it's not. It's more like a purple. 4 blue marbles. 3 red marbles. 5 green marbles. And let's see, where's the yellow? And 8 yellow marbles. I want you to tell me the probability of picking 3 green marbles back to back without or with replacement. Okay? I want you to tell me the probability of picking 3 green marbles back to back with replacement. Now, somebody tell me what is the denominator? You gonna hold your fingers up this time, Miss Jarrett? I'm picking on you. I appreciate you communicating, even though it was my fingers. All right. Somebody tell me, what is the denominator?
20.
Good. So you can put 20 as your denominator. Okay. So 5 out of 20. Raised to the third power. So this 3, in other words, you pick 3 times, that 3 is going to be that exponent. And without replacement or with replacement means you pick 1 marble out of the bag. Sorry. 5 out of 20. Then you put the marble back, you write the color down, you pick another marble, and you pick another marble. That gives you 5 over 20 raised to the third power. The third power is how many you picked. Okay? So if I would pick, what is the probability of picking all 5 green marbles back to back? This would be 5 and this would be 5. But since I said 3 draws, you put your hand in 3 times, what is the probability of getting all greens all 3 times? And that's 5 over 30. So you would take your handy dandy calculator and you would do 5 over 20 raised to the third power. And in this section, you want to round to 4 digits, 0.0156. Now, what have I said without replacement? The probability of 3 green without replacement. That means when you pull out a marble, you put it in your pocket. So 5 out of 20 is going to turn into what? What's the next pull? Remember, you put the marble in your pocket. So what's the next pull? Not 5 out of 20, but what?
4 out of 19.
And what's the next pull?
3 out of 18.
3 out of 18. Now we're going to multiply those. Parentheses, 5 out of 20 times 4 out of 19 times 3 out of 18. Round to 4 digits, 0.0088. Can somebody tell me if these two are the same? Are they equal? No, they're not equal. So when you're dealing with small numbers, these two are going to be different. With replacement, without replacement. Answers are different. But now I want you to add 2 zeros to each one of your marbles. So we're going to go over to the next page, and we're going to draw a big bag of marbles. And instead of 4 marbles, we got 400 marbles. 400 blue. 300 red. 500 green. And 800 yellow. Now what is the total? Well, we added 2 zeros to everything, so you're going to add 2 zeros to 20, Hubert. That's right, class. Now, I want you to do both the same thing. We're going to do the same thing. I want you to do both of them. Probability of 3 green marbles being picked out of the bag right behind each other with replacement. And the probability of 3 greens being picked without replacement. And remember, I want you to round to 4 decimal places. We go ahead and do that. Round to 4 decimal places. Take a minute and do both of those. All right. So the first one is going to be 500 over 2,000 raised to the 3rd power. So we take our handy dandy calculator and we go 500 divided by 2,000 raised to the 3rd power. 0156. That's the same thing, Hubert. Yep, it is. I know that. Remember, I got running water. 0.0156. Now let's do the next one. And that's going to be, let's see, 500, somebody help me out, over 2,000 times what? What's the next one? $4.99 over what? 1,999 and $4.98 over 1,998. So, parentheses, 500 divided by 2,000 times 499 divided by 1,999 times 498 divided by 1,998 and round to 4 digits, 0.0156. What do y'all ascertain from doing this problem? That means I want somebody to communicate. What do you see as far as this problem and this problem?
The answer's basically the same.
So we need, that's right, that's correct. So we need to come up with a rule. I would say probably after 300, and you could stretch it to 250, but after 300, it doesn't matter which method you use. So which one you going to go with? Which one's the easiest? The exponent. Unless you just like typing in a bunch of parentheses and a bunch of numbers, the best way to do it is raise it to the exponent. And if you have over 300 on each of these, you ain't going to have to worry about it because you're going to come out with basically the same answer. You're welcome. Because a lot of teachers don't show this. They don't show you that you get the same answer basically after 300. Now, what if one of these was 150? Well, then you would see a difference in that fourth digit. If like 300 was 150 and 500 was 200, then you would have two numbers that was less than 300, and then you might see a difference in this fourth digit. Does everybody understand what I'm saying? Yes or no? Thumbs up, thumbs down. Do you see? Okay. Thank you for communicating. Thank you so much. All right. And that's pretty much it. Question, gripe, complaint. I'm going to show you another question that you may see. And this is CDs, compact disc. You work at Cryovac, and Cryovac, I don't know how many of you, I think it's Cryovac. These are the people that actually create CDs. I know some of y'all don't know what a CD is, but anyway, it's a little round disc that you put information on. I know it's obsolete, but I'm using this example. Please forgive me. But you make CDs. Now, I'm not talking about 10 or 15. I'm talking about 10 or 15,000 in a pallet, all right, or a box. And you're working, and you're the quality assurance manager, and you walk up to a bin or a box of CDs that have just been created, and there's 4,526 in the crate. All right. In the past, 12% are bad. That means 88% are good. This is in the past. They want to know, and this right here, we got to go ahead and put this right here. So how many are good? Well, you take how many are projected to be good. You take 4, 5, 2, 6. 4, 5, 2, 6. Oh, me. 4, 5, 2, 6 times 0.88. And that's 3983. So 3983 are good. And subtract 4526. That means 543 are bad. And as a quality assurance manager, you're going to go pick 5. You're going to go pick 5 CDs. And if all are bad, you got to send this crate, send it back to wherever it came from in the plant before you send it to Walmart or Walgreens or whatever. Because if you send it to Walgreens, they have to deal with the bad CDs. But if you pull 5 in a row, then you're going to send this box back to where it was created in the plant and say, look, y'all got a bad box here. You need to fix it. So what do? Well, 5 is our exponent. And we want to see what is the probability of all 5 being bad. So that's going to be 543 over 4526 raised to the what? 5th power. So take your handy dandy calculator and you do 543 divided by 4526. And that's going to be raised to the 5th power. And you have a probability, that's going to be 4 zeros. So 0.0000249. Now, why was I not worried? Why was I not worried about the method? Because this is 4 digits. This is 4 digits. And this is 3 digits over 300. So it doesn't matter. Let's check it. 543 over 4526 times 542 over 4525, 541 over 4524, 540 over 4523, and 539 over 4522. So we're going to take our handy dandy calculator and do this tedious math. That's going to be 543 divided by 4526 times 542 divided by 4525 times 541 divided by 4524 times 540. Oops. 540 divided by 4523 times 539 divided by 4522 and equals 0.000245. 0.000245. And I'm sorry, but that's the what place? Tens, hundreds, thousands, 10,000s, 100,000s, 1 millionth, 10 millionths. Okay, so we got 4 10 millionths of a difference between the two numbers. I'm sorry, but 4 10 millionths, that's not, I'm not worried about that at all. Okay? So everybody got it? Yes or no? All right. Let me call, let's see, is everybody here today? Let's see, yeah, we got 15. All right, so let me go look at the homework for y'all right quick. And let's pull up your homework.
Priority 1 message coming in on secured channel.
Now somebody's blowing up my phone, wanting something probably. Math 12038. And assignments manager. And right now, your 4.1 homework. Yeah, I'm going to extend it to the end of today. That'll help y'all out a little bit. You're welcome. And that's, and 5.1 is due today. That's okay. And 5.2, I'm going to leave it open. And 5.3, I'm going to leave it open. Remember? Okay, we don't have 5.4 because we're going to skip that. All right. So anybody got any questions? Okay, then if nobody has any questions, y'all have a good day, and I'll see y'all Thursday. Send questions. See y'all.